Thank you very much. Thank you, Nadja, and the team for inviting me and organizing this fantastic event. So as Christina said, I'm Mathilde. I'm head of studies at IAAC. I will make a small disclaimer. I am an architect and my PhD is in urban design, so maybe I'm coming at additive manufacturing from a slightly different perspective than some of the other talks that we've heard earlier today. But I wanted to talk to you a little bit about the research that we've been doing at IAAC in relation to additive manufacturing, and in particular how we've been using that to create or innovate within the context of performative, inclusive, and resilient design for built environments. So firstly, just if some of you are not familiar with IAAC, we are a research, education, and digital fabrication center, and we're based in Barcelona. The institute is dedicated, it's quite a young institute, and we're dedicated to shaping the future habitat for our society. And what's really important is that we're dedicated to building it within the present context. Our activities are intrinsically related or intersected one within the other. So we're working with research within education, within development, and within promotion, with the idea of breaking down the boundaries between these different sectors and really creating a synergy between the practice or the professional realm and the realm of research and education. And we do this in order to be able to follow the digital revolution at all scales and push the boundaries of fundamentally architecture and cities in order to be able to meet the challenges that we face as humanity today. So I'm going to talk to you a little bit about the research that we've been doing in 3D printing architecture with Earth. It's a 10-year research journey, which in this presentation will culminate with a project called TOVA, and then I'll have one last little project on the end. But fundamentally, our work centers around this idea of negotiating between machine, design, and material. So fundamentally looking at not just the negotiation between the machine and the material, sort of developing new processes, new tools, in order to be able to sort of manage this situation, but also the negotiation of design from different perspectives, so from the design of the object, the design of the material according to the performances that we're after, the design of the section of the wall, but also the design of the architecture and the larger scale of the architecture within its context in the built environment. As Christina was saying earlier, so I don't repeat it, obviously our intention is to sort of face some of the larger scale challenges that we have within the context of the built environment and give a response to these in some way. So we started our journey in 3D printing architecture with clay in 2012. Actually, Christina was at IAAC at that time working on another project that focused more on the technology of 3D printing. But in parallel, there was research being developed called Pylos, which actually means clay or earth, if I'm not wrong, in Greek, and looking at developing a series of material recipes that would enable us to be able to 3D print with clay. So fundamentally, this research has been ongoing since the initial start of it, working with different mixes of clay, and as I think Dinora mentioned before, clay is different everywhere you find it, so obviously you need to adapt your earth mix or your mix for 3D printing to the specificities of the local clay. But we've been working with different aggregates, water, bio-based additives, and obviously mineral additives in order to create a material that can enable us to control its viscosity, the stickiness of the material, the capacity to absorb water of the material, the drying period of the material, and finally have some data and information on how the material will shrink once it is in fact printed. Further to this, obviously we have identified the need in some way to be able to integrate feedback loops. Can I hide the meeting panels? No? Okay, well, no, that's not. Sorry. Integrate feedback loops between the material itself the material that's being printed, to be able to understand through the printing process what it is that we can control and what do we have to do within that process. So specifically in one of the projects that we worked in on-site construction, which was actually a pavilion printed, you can see it on the left-hand side of your screen, a pavilion printed out in one of the construction fairs in Barcelona called Construmat. We were working with drones in order to be able to capture data and optimize the printing process within the actual printing period. So understanding the behavior of the material according to obviously the environmental factors that impact the material's behavior in itself during the printing process, and obviously to avoid any construction issues, among which buckling. From that project, we actually developed digital adobe, which is the project once again on the left. This was a 5-meter high wall that was printed in different pieces and then assembled on site. This was actually also another challenge. So when working with earth, we're also interested in working with earth and materials in order to be able to ensure its biodegradability, but also its, that it's a truly biodegradable material, but also that it has the capacity to be recycled. So the pavilion that you saw previously that was developed in Construmat, on-site construction, was actually crushed. And we use that same material to build digital adobe. So we do have, in some way, the proof that we can actually crumble the material, crush it, remix it, and reuse it for other projects, which is quite an important feat for us. Here, within the context of digital adobe, we're not just using the recycling of demolition waste, but we're looking once again at the capacity to optimize the infill, the space within the wall spaces, and also the exterior facade, in order for it to be able to have certain characteristics of performance, whether that be thermal performance or environmental performance on the architectural scale. Some other elements that we've been since researching is how we can integrate perforations. Obviously, when working with clay and additive manufacturing in a layer-by-layer process, we have the difficulty of how we integrate perforations, how we integrate openings within the architectural form. So one of the challenges that we've been working on is understanding how we can do that in different ways, from working with micro openings to small wind-catching openings, or medium windows and large passages or doors. In order to be able to do this, we've been working a lot on understanding what is the overhang that we can work with in the layer-by-layer deposition with clay without having to have any formwork, and how we can integrate that into the construction process and the design process within the system. So in the bottom, you can see in the center bottom, you can see some of the tests where we're really pushing it to an extreme, taking data and taking information on that and integrating that into our design processes. As I was saying, also we have a series of needs to, on one side, integrate openings, but also we have the question of the fifth facade. So how do we close or how do we seal off our 3D printed systems? We have been working over the past couple of years also at looking at vernacular processes or vernacular architecture to gain some inspiration. In particular here, the inspiration from vaulted systems. Working with this and understanding once again what is the limit of the overhang that we can work with when working with layer by layer, and what are the integrations within the design system, such as ribs or buttress systems that we need to integrate in order to be able to ensure a structurally sound system. And finally, if we really want to push that, how we can integrate potentially formwork systems in order to push the limit of this cantilever of the layers and work beyond what the material would be accepting. Here we're working on the use of formwork that is designed to be installed during the printing process and uninstalled, so in some way recyclable formwork, and the potential of working with a combination of wood and earth, so the negotiation between the different natural materials and how that would impact the actual architecture in itself. With all of this, we have a series of, let's say, outputs or considerations that we work with on the architectural scale of design, from choosing the geometry to a certain set of structural desires in order to foment or push the design. So from inertia, global and local inertia, inclination, and a series of questions of mass. All of this is oriented to, in some way, being able to adapt the specificities of the architecture to the micro-local context of the architecture. So we are working with additive manufacturing, which is a form of digital fabrication. We have the possibility to customize, really, the architecture, the shape, the form, to the necessities and the specificities of each specific location of the elements. So we work with the idea that the walls can all be different and respond to very localized conditions. Among some of these performances, we work with the question of heat conductivity. So obviously, clay in that sense is a very interesting material to work with thermal considerations. We also work with airflow as a design driver. And finally, also, of course, with water flow and understanding how we can sort of integrate different elements within the design system in order to be able to capture, leverage, or protect the building accordingly. The last and not least, of course, the architecture and the spaces that we design are designed to interact with humans. So we have been looking also at how we can integrate different systems that are necessary in some way and integrate ergonomics as a design driver also. So all of this culminates in the project, in the development of a series of architectural projects. So in parallel to working with, as I was saying, these design negotiations, or the negotiation, of design between material and machine, we're also looking at what this means, how do we scale this up, and what could this mean in different contexts, of course. So how can we adapt this material system to different specific contexts? So here we have a series of images that can give some ideas or visions of how that might be. But I want to take you to one specific project, which is a project called TOVA. Of course, as I was saying before, and as Christina mentioned, one of the questions that is very interesting when working with clay is the possibility to really create an entirely on-site process, and really working with not just 0 kilometer material, but almost 0 meter material. So how we can embed resiliency, but also very, very localized processes into the actual construction site. So with this feat or this challenge in mind, we started developing TOVA, which is a project, prototype, developed by our researchers and also the students of the 3D printing architecture postgraduate program that we run at IAAC. This is the actual project where you can see from the foundation material to the wall systems, to the integration of other systems such as wood and the roofing system. So this is in some way a culmination of all of the steps that I showed you previously in the presentation. This is the final picture of TOVA. So TOVA will be turning 2 in February. She's a February baby just like me. And so I invite you all to come visit TOVA in Barcelona. TOVA, here you can see on one side, and here on the other side, as you can see, we're looking at adapting the design. I will play, of course, and all of this is designed fundamentally. This is here in our Valdaura campus, which I will explain a little bit more about now. But fundamentally, all of this is designed in order to create visions, again, for an architectural scaling up or an understanding of how these methods could become replicable. So if the video works, we will play the video of TOVA. Okay, so this here is our Valdaura labs. We are very lucky to have a campus just 20 minutes away from the center of Barcelona in the Collserola Natural Park. So here we built TOVA, also digital adobe, and some of the other prototypes that I was showing you before. This is basically the extraction of the clay material, and here we have the mix of the sincel fiber, enzymes, and water in order to be able to produce the material mix that we were working with. This project is a collaboration with WASP, so we used the WASP 3D printer in order to be able to print this out. And the printing process took, I think, just over a month, if I'm not wrong. So once again, here we see the different steps that I was discussing previously in the presentation, from optimizing the shapes of the walls for certain performances, from heat, thermal performances, but also the integration of ergonomic conditions. We also have the integration of a roofing system, which works with timber. Locally sourced timber, of course, and fundamentally what we're doing here with TOVA is in some way attempting to respond to some of these challenges. There was a huge team that made this project possible, so of course huge thanks to them as well. Let's see if I can go forwards now. Okay. Sorry. A little bit of happiness to share with you. TOVA recently won one of the New European Bauhaus Prizes for 2023 in the Shaping Circular Industrial Ecosystem and Supporting Life Cycle Thinking category. So it was one of the top 5 projects and one in the strand of champions. It was also selected as the I think best house or best living unit on the Spanish Art Daily platform, which was also really nice. So that's a public voting. So that's a great feat for us there. And just to close, I wanted to take you through another project, which also is based around 3D printing, looking at this time inclusive design strategies. So the project is Comida. It's a project that was funded by Bid Habitat, which is a local funding scheme or an agency that provides local funding schemes in Barcelona. Comida is the implementation of a 3D printed wall system that is co-designed. It's been co-designed together with the citizens of 2 specific spaces. One is Connect Art and one is Passage de Trullas. Both of these spaces are spaces in Barcelona that are run by collectives. And fundamentally, Comida is designed in order to be able to host plants, plants that have different benefits, of course, integrating nature-based solutions into the 3D printed system, but also has the capacity to generate biophotovoltaic energy. So here is Comida. Comida is a modular system. This is my beautiful colleague, Chiara. As you can see, this system is designed, as I was saying, to host plants, growing food producing plants, but also hosting many different species. So looking at, once again, the opportunity or the possibility of working with more than human design. So integrated into the Comida wall system, we have a series of spaces that can host birds and bats, but also insects. And finally, we have a series of cultivation spaces or spaces that are designed to host microbiota. Last but not least, we have a management system integrated. So Comida, as I was saying, has the capacity to produce biophotovoltaic energy. So fundamentally, the plants, when placed in soil, produce bacteria in their roots when they go through the photosynthesis process. And by integrating an anode and a cathode within these different modular systems, we have the capacity to capture these these bacteria in the form of electrons. As you can see here, the vases have different topographies or surface finishings according to their specific location on the wall and designed in order to host certain microbiota. With the energy that we are able to produce, we power our sensing system on the wall system, and we are able to capture some information, including, for example, the temperature, but also the humidity of the top vases to understand when we need to activate the watering system. This is a picture, a more recent picture. So here you can see that already the system is changing color, is capturing a little bit more of the, let's say, biological matter that is growing around. Of course, on an urban scale or on a larger design scale, this brings the question of what we can do with the different blank facade systems that we have around our urban environment, and how we might be able to reimagine these. Also leveraging smaller scale systems in order to foment, for example, large scale ecological connectivity within our urban environments. And just to close, I will play a little video of comida. Yeah, maybe. Yes. Okay. So comida once again looks at responding to the challenge of our urban environment and how we can integrate living systems or natural systems within those. The wall was designed, parametrically optimized and shaped in order to be able to host more than human necessities. We 3D printed the modules out at IAAC, and they are done in clay. The clay has not been glazed on purpose. This time the clay is fired, whereas in the other houses the clay was not fired. And fundamentally, this is in order for it to become a host for biological matter. The system or the use of 3D printing, of course, allows us to minimize the waste that we generate in the production of the wall system. And here we collaborated with Cumeia Cerâmica. Tony Cumeia is the owner of the Cumeia Cerâmica company. And as I was saying, we have a diversity of design of the different modules. So according to the requirements or the microclimatic conditions of the wall system, we can adapt the placing of these elements. It's, again, embedded with a biophotovoltaic system. And the process was all co-designed together with the users of the spaces of both, as I was saying, Connect Ort and Passage de Turrias. Here the setup of the modular system, which hangs off a structure. And we have a web app and a Telegram API that allows us to sort of interact with users, but also collect and share data. This is the co-design process, working with the users of the space. And fundamentally, the idea is that, as I was saying before, we discuss a little bit what are the potentials of the built environment and how we can integrate a diversity of systems within our architectural form. And with that, I would like to thank you for your attention. I'd also like to take the time to thank my colleagues. Of course, these are all incredibly collaborative efforts, so huge kudos to them. Thank you.
Thank you very much, Mathilde, for the wonderful presentation. Do you have any questions from the audience?
Hello.
Hello.
Thank you very much. Nice, very nice presentation and very amazing project. I'm really curious about this clay project because clay is really difficult to handle with. First, the shrinkage. Like, did you measure like how much is shrinkage of your object? And then I saw it's a hollow things, and I'm also curious about how you dry the inside of the hollow, because sometimes, most of the time when the one is outside is dried first and then the inside is still wet, it will cracks out of it. And then, yeah, so what is the strategy of avoid the crack? So is there any cracks in your project? And did you print it in the contained environment? Because I didn't really see it.
Yeah.
Is it outside? And then...
I hope I remember all these questions.
Yeah, yes, that's true. Thank you.
Okay, no, thank you. So shrinkage, yeah, we've been measuring shrinkage since the beginning of the research. It's actually one of the input design parameters. So from the smaller scale tests, we have that as an input. So we have data that we've been collecting over the last 11 years. With regards to printing, the TOVA project was printed outside. On site with the WASP crane printer. We are constantly collecting feedback. So in an earlier slide in the presentation, I showed on-site construction where we had integrated sensor feedback systems in order to be able to capture information on how, for example, how dry the clay was before starting to add layers. So we have a constant feedback between the actual process of construction and the inputs of the construction in itself. So that allows us to capture this information. It's true that it dries faster on the inside, but it's also true that we built Tova in the wintertime, so a very, very humid moment in general in Barcelona, and that creates a kind of condition where the environment is quite homogeneous, let's say, between the inside and the outside of the wall. Of course, if we were printing in the summer, it would be a completely different situation. We do have some projects were printed in IAAC, so like inside our facility. And of course, the on-site construction was printed in the construction fair in Barcelona. So those are like different, but always with this integration of feedback.
I would have one question, Mathilde. How do you experience the co-design process with community, right, with people who have never maybe experienced this type of technology and this type of design process, and how do staff members experience it?
Obviously the co-design process is guided to some extent, so not all of the design questions are necessarily co-designed, but rather we are sort of placing options and also creating a condition by which the people who are interacting with these spaces have an understanding of what are all of the benefits or what is the innovation that they are dealing with. No? So there's a learning process, an understanding, I guess, a metabolizing process, and then a negotiation process between experts, so obviously people who have understanding, and the users of the space. I have to say, these two spaces that we did the co-design process with are collective spaces, so they have a very strong community. In general, that makes a huge difference when you have a community that is highly sort of invested in the outcomes of whatever project you're doing.